All right, so our data is imported, and now we're going to run our very first linear regression model. Hope you're excited about this. Let's get straight into it. So in Gradle, we need to click this menu up at the top, model, and then we'll just select the ordinary least squares, which is our simple linear regression. So here we're going to take salary and we're going to put it into the dependent variable because that's the variable that we want to predict. And years of experience, we want to put it into the regressors. So that's going to be the independent variable, and we want to see what is the relationship between salary and experience. And also here you see that there's a variable here by default, which Gradle puts in there for you. It's constant. It's always going to be there by default, and we're going to leave it in there as well. Okay, so we're going to click OK now. And voila, this is the magic screen. So if you have not seen this before, then you should start getting used to it, because depending on how you structure your data science career, you will either see this a lot and all the time, or you might see it occasionally, infrequently, but you will still eventually have to deal with this report, and this is actually the result of running your model. And this report will be exactly the same wherever you run your regression, whether it's in SAS, SPSS, R, Python, anywhere. The report will look like this. So let's learn how to read this report, and let's learn how to extract the valuable data that we need. So at the top, you've got the observations that were used, the type of regression, so ordinary least squares in this case. Then you've got the dependent variable name, it was salary. Next, there's two parts, this part and then this part. This part is a breakdown of information, of statistics per independent variable. Right now we only have two independent variables, so the constant, which isn't actually a variable, it's just the constant, and then we've got this independent variable, years of experience. And then here you've got information which relates to the model overall. So let's start with the first block. What are we seeing here? Well, here you see the coefficients. Those are the coefficients that we discussed in our formula. And constant being $25,792.2 means that the line of the linear regression crosses the vertical axis at 25,792.2, which means that if you have 0 years of experience, so if this variable is 0, then according to this model, your salary should be $25,792.20. And then the coefficient for years of experience is $9,449.96. What does that mean? Well, that means that for every 1 year increase in experience, the salary goes up by $9,449.96 in the modeled world. So it doesn't necessarily happen like that in real life, but from what we've modeled, and we'll see that in a second when we look at the graph, this is the way things work in the modeled world. With somebody with 0 years of experience starts with this salary, and then for every year of experience, the salary increases by so much. And if it's a fraction of a year of experience, so if it's half a year, then it'll be an increase of half of that. And that's all in line with the linear regression formula. Then you've got the standard error here, you've got the t ratio, and you've got the p-values for each of your constant or variables. In this section, or in this part of the course, we'll be focused, of course these are all important, and it depends on what you're doing with your data science project. You might need to work with these, but in this particular part of a course, we're going to be talking about the p-values mostly. Why? Well, that's because the p-values allow us to understand the statistical significance of individual variables, and we will be focusing on this quite a lot in the further sections of this part of the course, because it will allow us to filter out variables that are not actually predicting anything. So I'll give you an example here. Right now the p-value is very, very small, so it's 1.14. It looks quite a lot, but then you got to multiply it. This over here is a scientific term for 10 to the power of minus 20. So you got to multiply 1.14 times 10 to the power of minus 20, which makes it a very, very small value, tiny value. And well, that is a good thing. The smaller the p-value, the better. that means that this variable actually predicts something. So if you had a p-value which is great, which is quite high, for instance, even higher than 0.05, so in percentage terms, higher than 5%, that is already considered a high p-value. And what it's saying is that when you change the independent variable, it won't actually be associated with any change in the dependent variable. So you can only, you got to pick, and we'll talk about this further in this part of the course, in the modeling part of the course, but you got to pick a threshold for your p-value. So for instance, if you stick to 5%, which is probably the most used p-value or the conventional p-value threshold, then if your p-value is above 0.05, so if here you see above 0.05 and there's no multiplying by 10 to a very negative number, then that means that your p-value is above 5%, and that means that the relationship between these two variables, salary and years of experience, isn't statistically significant. And so basically your model in layman terms, it's not actually working. So this variable is not predicting anything. So that's how you read this part of the report. Let's move on to the second part. So here you've got some stats about the model overall. And the ones that we'll be focusing on in this course that are most important to us are the R-squared over here and the adjusted R-squared. And we've already spoken about these two parameters back in the previous section when we were talking about refreshing our stats knowledge. So we will see how we're going to be using them further in the course, especially when we're building our customer segmentation model further on.